In the event that we erase the boundaries, the most enticing celestial body I recognize is the one that might be extraordinary in our sky. It is this one, Betelgeuse. Betelgeuse is a massive red supergiant star, and if you were to position it where our Sun is, it would extend all the way out to Jupiter's orbit. It is so massive and extremely unstable that it is on the verge of exploding. However, it is not as straightforward as it may seem. These enormous celestial bodies behave in ways that can surprise us. Events like the most extreme supernovae could shake everything we observe, and even things we are unable to see clearly. Betelgeuse is considered a prime example of a red supergiant star, typically much larger than our own Sunday. Brian Cox, along with other astronomers, believes it might explode in a supernova soon. People have grown increasingly concerned about what will transpire because the James Webb Space Telescope has been capturing remarkable images of the star. When exactly will Betelgeuse erupt into a supernova, and how significant will the impact be on Earth? Let's delve into this star in the magnificent Orion constellation, which shines so brightly that even ancient civilizations noticed it. The splendid star Betelgeuse resides on the eastern shoulder of the Orion constellation, ranking as the second largest star in Orion. Its name derives from this location, marking it as a shoulder star. Betelgeuse is one of the brightest stars visible in the night sky. In addition to its brilliance, the star emits a peculiar hue of red, which signals potential danger. Humanity has long studied Betelgeuse. The Greek astronomer Ptolemy observed it long ago. At that time, the first thing people recognized about stars was their color. His observation was that the star appeared to have a reddish-orange hue, an alarming indication. In recent years, scientists have studied the star with even more precision and now have a much clearer understanding of what makes it so strikingly luminous. One of these factors is that the star undergoes substantial variations in brightness, fluctuating by as much as 0.6 magnitudes. Betelgeuse is a variable star, meaning its brightness shifts frequently. In 2019, researchers discovered some new behaviors in the star that had never been observed before. Even though Betelgeuse didn't stop shining completely, its luminosity significantly decreased. It dimmed to a level of around 1.6 magnitudes, causing experts to investigate the reason behind this irregularity. They hoped to find an explanation for why Betelgeuse was behaving so erratically. According to their findings, Betelgeuse could explode as a supernova at any given moment. Brian Cox, a renowned scientist, shared this alarming evaluation. As an outstanding professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement with Science, his opinion carries weight. He also presents popular science TV shows and writes books, making his perspective well respected. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with little warning. To support this claim, the James Webb Space Telescope has provided substantial evidence. However, several peculiarities about Betelgeuse have raised many questions. Why does Betelgeuse act so strangely in terms of its variability? With the new data, Betelgeuse has earned its place as a candidate for a supernova. However, researchers still don't know when the explosion will take place. The fact that Betelgeuse's mass is nearly twice that of the Sun supports this classification. Generally, stars with at least several times the Sun's mass are considered potential supernova candidates. The plot thickens, though, because scientists have used different tools to investigate Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to uncover mysteries surrounding the star. What they've uncovered is still shrouded in mystery. Betelgeuse was born a very long time ago, on August 31st, and since then, the star has been offering strange signals that keep its future uncertain. What did they discover? They detected peculiar light waves emanating from the star, raising further intrigue. But this wasn't the only strange occurrence. It brings us back to Betelgeuse's variable nature, its fluctuating brightness. There were reports that Betelgeuse had regular darkening episodes akin to sunspots on our own Sun, but its cycles were different. It shifts between bright and dim phases twice as rapidly as it once did. Another peculiar indication that Betelgeuse is misbehaving came when researchers observed that, in February 2021, the star's dimming cycle reached a brightness band of plus 1.61 magnitudes. This was not long after the star had experienced a massive dimming event, marking the beginning of its abnormal behavior and raising alarms that Betelgeuse might be nearing the end. The significant dimming between 2019 and 2020, when it fell to its lowest point, convinced many experts that the star would explode within the next 100,000 years. However, when Betelgeuse brightened once more after this unprecedented dimming, things became even more bewildering. As physicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted, the star was currently 150% brighter than usual, making it the seventh brightest star in the sky. Researchers were astonished to see a red glow emerging from the southern part of the sky, further puzzling the situation. This development sparked numerous theories about the cause of Betelgeuse's great dimming. It is essential to highlight that not every star radiates the same red glow as Betelgeuse. This glow marks it as a red supergiant star, the final phase of a star's life before its death. This red hue is the result of a surface temperature around 3,500 Kelvin, significantly cooler than the Sun's outer layer, which is around 5,500 Kelvin. Since Betelgeuse is cooler than the Sun, it radiates less energy per unit of surface area, even though it is much larger and on the brink of exploding. We should also consider the extraordinary dimming event that Brian Cox questions. Does it really mean Betelgeuse will go supernova? The fact that Betelgeuse is already in its red supergiant phase indicates that it is nearing the end of its life. A star in this phase will often dim as it dies, and this is something scientists can detect. However, Betelgeuse's recent unusual behavior has made scientists even more focused on monitoring it. Today, multiple telescopes are focused on this mysterious dimming event, trying to gather more insights. Things continue to become even more intriguing. As a result, researchers do not yet possess a comprehensive understanding of Betelgeuse's behavior. Using cutting-edge instruments, scientists are watching the star closely. The James Webb Space Telescope has been one of the most valuable tools since its launch in 2021, helping astronomers gather new, important information about Betelgeuse. The telescope's images of the star's remarkable dimming have shown that the event caused an enormous mass ejection, more than 400 billion times larger than a typical coronal mass ejection. The James Webb Space Telescope can also observe things invisible to the human eye, such as specific light wavelengths and frequencies, making it an extremely valuable asset. Researchers have observed dust clouds forming on the star's surface that appear to resemble leaves in space, an odd but fascinating finding. When Betelgeuse eventually explodes, it will release an immense burst of energy, briefly outshining the entire Milky Way galaxy. The supernova will be visible from Earth, even during the daytime, and will appear as bright as the full moon in the night sky. This event will provide astronomers with a rare opportunity to study the final moments of a massive star in real time. One of the key aspects of Betelgeuse's eventual explosion is the impact it could have on its surrounding cosmic environment. A supernova of this magnitude will generate a powerful shockwave, dispersing heavy elements such as carbon, oxygen, and iron into space. These elements are essential building blocks for planets and even life itself. In a way, Betelgeuse's death will contribute to the formation of new celestial bodies, continuing the cycle of stellar evolution. Despite its dramatic end, Betelgeuse is too far from Earth to pose any direct threat. Some people worry about the potential effects of the explosion, such as gamma-ray bursts or radiation exposure. However, scientists have confirmed that Betelgeuse is not close enough for its supernova to have any harmful effects on our planet. The only noticeable impact will be its stunning brightness in the sky, which could last for weeks or even months before gradually fading away. The exact timeline of Betelgeuse's explosion remains uncertain. While it could happen within our lifetime, it is also possible that the event may not occur for another 100,000 years. Astronomers will continue to monitor the star closely, using advanced telescopes and observational techniques to detect any signs of impending collapse. For now, Betelgeuse continues to fascinate scientists and skywatchers alike. Its erratic behavior, sudden dimming events, and fluctuations in brightness make it one of the most intriguing objects in the universe. Whether it explodes tomorrow or millennia from now, one thing is certain. When Betelgeuse goes supernova, it will be one of the most spectacular astronomical events ever witnessed by humankind. Opportunity for scientists to study the final stages of the events and life of a massive star associated with an event that is so explosive. Betelgeuse's inevitable demise is not just a scientific curiosity but also a reminder of the vast and unpredictable nature of the universe. Stars like Betelgeuse play an important part in the life cycle of galaxies, enriching the cosmos with elements essential for the creation of new stars, planets, and potentially life itself. The death of such a star is not an end but a transformation, as it releases heavy elements that will seed new stellar systems. In the meantime, scientists continue to observe Betelgeuse, piecing together the puzzle of its future. With each new discovery, the mystery surrounding it grows deeper, expanding our understanding of the universe. With every piece of the puzzle uncovered, perhaps in the years to come, we will witness one of the most extraordinary events in the cosmos, the transformation of Betelgeuse from a massive red supergiant into a stunning supernova. Until then, the sky will remain a canvas of wonder, with Betelgeuse shining brightly as a reminder of the fleeting nature of life in the universe. Betelgeuse's transition into a supernova is an event that will capture the attention of astronomers and skywatchers alike. Even though we are unsure when exactly this transformation will occur, the star's current instability has sparked a wave of speculation about its future. The advanced instruments and technologies at our disposal, such as the James Webb and Hubble space telescopes, have provided astronomers with unprecedented insights into the behavior of this remarkable star. As Betelgeuse's brightness fluctuates and its erratic changes continue, scientists pay close attention, studying the data in the hopes of understanding what triggers these shifts. The extreme variability of the star could be a precursor to the violent explosion that will ultimately mark the end of its life. Whether Betelgeuse will explode within the next few years or in a much longer time span remains uncertain. One thing is clear: the universe is full of cosmic surprises, and Betelgeuse's eventual demise will be a spectacle that brings new opportunities for discovery. Throughout the centuries, astronomers have observed and studied countless stars, but few have garnered as much attention as Betelgeuse. Its immense size, variable brightness, and unusual color have made it a subject of intense research. As a red supergiant, Betelgeuse is already in the final phase of its life cycle. The star's massive size means that it will eventually exhaust its nuclear fuel, leading to its ultimate collapse and subsequent explosion into a supernova. This explosive event will release an astonishing amount of energy, significantly modifying the cosmic environment. Despite the many uncertainties surrounding the exact timing of Betelgeuse's supernova, astronomers agree on one thing: the star's eventual demise will be one of the most significant cosmic events to occur in our lifetime. The data being collected by the most advanced telescopes today contribute to the mysteries of the star, providing crucial information about the processes that occur during the final stages of a star's life. By studying the behavior of Betelgeuse, scientists can gain deeper insights into the broader mechanics of stellar evolution. In addition, the explosion of Betelgeuse will likely leave behind a lasting impact on the surrounding space, enriching the interstellar medium with heavy elements that will eventually be incorporated into new stars, planets, and possibly even organisms. This cycle of creation and destruction is a fundamental aspect of the life cycle of stars, and Betelgeuse's supernova will be a prime example of this cosmic process. As we continue to monitor Betelgeuse and other stars in similar stages of evolution, astronomers utilize cutting-edge technology to better understand the forces at play. The James Webb Space Telescope, with its unparalleled ability to observe distant objects in the universe, is providing a wealth of data that will shape our comprehension of stellar dynamics. Images and measurements captured by this telescope are helping to shed light on the complex mechanisms that drive a star's evolution, from its birth to its finality. Even though the death of a star may appear to be a catastrophic event, it is, in fact, a crucial step in the ongoing cycle of stellar evolution. The elements released during a supernova contribute to the formation of new stars, planets, and the possibility of life. In this sense, the death of Betelgeuse, and stars like it, is not an end but rather a transformation that fuels the birth of new celestial bodies. As such, Betelgeuse's supernova will play a significant role in the ongoing evolution of the universe, contributing to the creation of the elements that will be used by future generations of stars and planets. Until the day Betelgeuse finally explodes, astronomers will continue to observe and study its behavior, piecing together the clues that will help them predict its future. The star's unpredictable dimming and brightening cycles, as well as its other unusual behaviors, make it a fascinating subject of study. With every new discovery, scientists are learning more about the processes that govern the life cycle of stars and, by extension, the evolution of the universe itself. The mystery surrounding Betelgeuse's fate serves as a reminder of the vastness and complexity of the cosmos. The universe is filled with untold wonders, and the study of stars like Betelgeuse allows us to glimpse the incredible processes that shape the fabric of reality. As we continue to explore the cosmos and deepen our understanding of the forces that govern it, we are reminded of the fragile, transient nature of life itself. The stars, including Betelgeuse, shine brightly in the night sky, offering a glimpse into the extraordinary and ever-changing universe in which we live. As Betelgeuse inches closer to its inevitable fate, astronomers remain vigilant, carefully analyzing every fluctuation in brightness, every pulse of energy, and every shift in its outer layers. While no one can predict the exact moment of its collapse, the data gathered so far suggests that its time is drawing near, at least on a cosmic scale. When Betelgeuse does finally explode, the event will be visible from Earth, potentially even during the daytime. The explosion will outshine the full moon for weeks, casting an eerie glow across the night sky. Such an event would be a once-in-a-lifetime spectacle, captivating both scientists and the general public. It would serve as a rare opportunity to observe a supernova in real time, providing invaluable data that could reshape our understanding of stellar death and rebirth. The remnants of Betelgeuse's explosion will likely form a neutron star or, if the collapse is extreme enough, a black hole. These remnants will continue to influence their surroundings, shaping new stellar nurseries where the next generation of stars will emerge. In this way, Betelgeuse's end will mark the beginning of something new, a powerful testament to the cyclic nature of the cosmos. Beyond the scientific significance, Betelgeuse's supernova will remind humanity of the impermanence of even the most massive celestial bodies. While stars seem eternal in our short human lifetimes, they, too, have life cycles that span millions or billions of years. Their births, evolutions, and eventual deaths shape the very fabric of the universe, influencing everything from the formation of galaxies to the very elements that make up our bodies. As the world watches and waits, Betelgeuse remains a beacon of cosmic wonder. Whether it explodes tomorrow or thousands of years from now, its story continues to unfold, offering us a glimpse into the vast, dynamic processes that govern the universe. Until that day arrives, we will continue to look up at the night sky, marveling at the mysteries that still lie beyond our reach.